Good morning and welcome to all the participants. Today we have Dr. Naveed Sabir with us, Principal Scientist CPCT IARI New Delhi. And today the topic of deliberation is IPM and gap for climate smart and sustainable product protected cultivation. So you are audible as well as visible. You can start the slideshow and start with the presentation.
Thank you very much. First of all, let me thank you for giving me this opportunity to be around with you digitally. I'm speaking on IPM and GAP for climate smart agriculture and sustainable protected cultivation, actually. Since I can safely presume that most of you may not have been told about protected cultivation, I'll give a brief idea about it. The protected cultivation is basically, I wrote long back, that it is precise, progressive, and parallel agriculture. Precise in terms of efforts and optimization of resources, of time, of management. Progressive because it is using the high-end technologies and the best of the technologies available. And parallel agriculture in the sense that just hold on. So it is precise, progressive, and parallel agriculture. Parallel in the sense that it is agriculture only, just like open field cultivation, but it is using some principles of agriculture and the same set of practices, they get changed slightly so that we can control biotic and abiotic factors. Okay. So for example, in the open, you cannot control the rain. You cannot control the humidity overall or the temperature overall. So in the greenhouses, you're trying to control. Now this control could be limited. This control could be exhaustive, and control could be nearly complete. So that depends upon how much, what kind of structure you choose, what kind of investment you do, what kind of energy availability is with you, how much investment you can do. What is the selection of the crop, depending upon the area, depending upon these factors. So you are similarly trying to control the pests and diseases, sometimes completely in the sense that you are using soilless cultivation. Hello? Can you hear me?
Yes, we can hear you.
Am I audible?
Yes, sir. Yes, sir. You're audible.
Okay.
Participants are requested to mute their microphones.
Because I'm getting a lot of voices from in the background.
I muted, sir. Can you start the slideshow?
Yeah, no problem. So that is why we say that it is a precise, progressive, and parallel agriculture. And if we consider it in comparison with the traditional agriculture, with the small holdings, low productivity, lack of education and knowledge, lack of irrigation facilities, rain-fed farming, low mechanization, climate dependence, negligible flow of institutional credits, poor access to technology.
यहाँ पर जो भी डेलीगेट्स वगैरह आएंगे आसपास ना लेकिन प्रमोशन ज्यादा हो बल्कि
Lot of noise in the background.
I've muted the person, please. If not, we'll be forced to remove the people who are not muting their microphones.
And similarly, unprofessional approach, unorganized marketing, low risk-taking abilities, and poor export linkages or almost nil export linkages. So whatever is increasing the productivity in terms of knowledge, resource, professionalism, and rest of the market is not available in the traditional systems of the agriculture. Whereas in the high-tech agriculture, the farms are professionally managed, we achieve higher productivity, we get advantage of the non-season or off-season, the buying power and investment capacity of the individual is higher, the understanding of the technology, availability of the technology, and application of the technology is at the higher level. Access to inputs and higher mechanization is available. Climate modulation and climate savvy and climate smart systems are available these days with the help of different kinds of sensors. If need be, we will discuss different kinds of sensors. Credit subsidy is available because money begets the money. The rich people can get big loans. The small farmer cannot even afford a good loan because it's a burden on him. The approach is entrepreneurial. Marketing is organized. Risk-taking capability is higher because they have a lot of money, so only some of it is diverted. Whereas the farmer, more often than not, he is investing season to season, everything that is available at his disposal. And if done properly, then the considerable amount of export is also available. So that is why the protected cultivation in the country was started, so that the technology could be best utilized. And since our country is facing continuously due to rising population, the fragmentation of the land is happening very, very aggressively, to the tune that hardly on an average 1 to 2 acres of land is available to the farmers, which is not good enough to sustain the family income for a healthy living, for meeting all the needs. So that is why the government introduced this technology, so that even from small areas, you could harvest better yields, better quality, off-season things, and in an entrepreneurial mode, in a business-like and professional approach, you could do much better agriculture than otherwise expected. So this is how the protected cultivation is started. So when we say that it is a protection from biotic and abiotic stresses, so it doesn't mean that it is a foolproof thing. It's not that we are able to fully control the temperature or something. These stresses, they remain. Similarly, you're not able to control all the diseases and all the pests. So there is a range. Although in open field cultivation, the number of the pests is more, but in the protected cultivation, whichever pest is able to establish itself is a very, very hardy one. And it is very difficult to control, and it multiplies very fast. That is why the intensity of the pestilence is much more in the protected cultivation, but there are only few pests. For example, the more often than not, most of the greenhouses facing a root knot nematode problem or soil-borne pathogen problem, or the sucking pests like insects, mites, aphids. Okay, so these are the things. So just before the protected cultivation in the country,
Question and answers would be at the end. Please stop raising hand.
no, if there is too urgent, you can ask.
Dr.
Yes.
Vignesh, if you have a question, please ask. Please do not break the flow of the presentation.
Now, before the protected cultivation took roots, the green revolution had set in a different era of high productivity, wherein high yielding varieties, intensive use of fertilizers, intensive use and an extensive use of the chemicals, which had already created problems. Now, other than the land fragmentation, the other problems the farmers were facing at large were the soil degradation and erosion due to continuous cropping, heavy use of synthetic fertilizers and chemicals, the water depletion, the water table was continuously getting receded, even the water quality was getting worsened, The loss of biodiversity was happening due to intensive cultivation. Lot of minor crops went away because the area that was covered by them had gone due to monocropping, extensive cultivation, or due to market inavailability or not availability of the professional market. So this was a very, very serious loss of biodiversity, and it is the biodiversity which survives us. Similarly, the pollution and eutrophication of the soil and the water bodies was happening. The greenhouse gas emissions were creating other problems like climate change and things related to like livestock methane production or nitrous oxide emissions and all that. Then even in agriculture, the pollution due to leaching of the nitrates was happening. So the pollution, eutrophication, and greenhouse gas emissions, they were very, very day-to-day problems for the nation at large, in totality. Not that individual farmer was facing these problems. The increased pest resistance. So when the dangerous chemicals are used repeatedly, the insects develop resistance, and they either need the higher dose for the control or they become totally ineffective. And out of desperation, then the farmers use more and more pesticide repeatedly, even 30 to 60 chemical applications by the by the farmers have been reported in different crops. So that led to the health risks also. Now, these kind of stresses on agriculture, apart from the labor problem, the market problem, the farmers were facing serious consequences. So protected cultivation gave a hope that from a small area, if you could control the biotic and abiotic factors, so it had several advantages. So advantages in the sense that you can control biotic and abiotic stresses, you can get higher productivity, 5 to 10 times, even more as compared to open field cultivation, higher quality and continuous availability of the. If somebody else has covered this topic, I can avoid this. Hello, hello. High quality and continuous availability, off-season production, minimized use of pesticides. Hello, amenability to organic. Hello, the coordinator is available. Similarly, the adoptable as agri-entrepreneurship and optimizing natural resources, income and employment generation, better as compared to open field cultivation. The employment was higher. For example, in the open field cultivation, if you require 1 to 2 labor per acre, in the protected cultivation, you require 3 to 4 labor per acre. So it doesn't mean that it will lead to more expenditure. The thing is that if you can get more income, the more profitability. So even if you are employing higher number of labor, it does not matter much because it is giving you the productivity and profitability even with higher number of. So it becomes an added advantage in the sense that there is better employment generation. Then this kind of cultivation is also suitable for peri-urban areas because in the protected cultivation, we grow mostly vegetables, and in the cities, the demand of the vegetables is very high, and they get good prices also. So peri-urban areas were particularly the ones. Hello. So there are different kinds of structures: climate control, semi-climate control, naturally ventilated structures for polyhouse type of things. Then insect-proof. Hello.
बता नहीं रही कौन सा पता है यहाँ का वो जिसपे खाता है ऐसा बता रहा है कि हमको मिल नंबर पूरी बताई हाँ और खड़े हो जाइए तो ये सर ये करके ऐसा ये नहीं पड़ा इसका भी
Hello. Hello.
बिक्री में नहीं है
Hello. So the key challenges faced by protected cultivation in India, it's not that the protected cultivation, if you construct a greenhouse and start the cultivation.
हाँ सर
Hello. Hello.
Dr. Rajnish is requested to please mute your mic from Atari.
Hello. So the because the greenhouse cultivation requires
इक्कीस से एक प्रोजेक्ट हमें आ रहा है 16 करोड़ का वाटर सेट पे
बढ़िया
hello.
कल एक प्रोजेक्ट मेरा सेक्शन 4 करोड़ और 84 लाख
अरे भाई पीछे से लगातार आवाजें आ रही है, मैं क्या बोलूंगा इसका।
Admin is requested to mute the all the participant mic, please.
हाँ लाल बिल्कुल
भाई ना टाइम में बनाए 4 करोड़ 82 लाख मंडी सौ बेड का फार्मर है एकदम का फार्मर है
तो सारा प्रोग्राम नहीं हुआ
ये भी क्यों नहीं हुआ पिछले 2 वर्ष में 2023 में लाए थे 2 करोड़ 17 लाख मंडी में
Hello.
Yes, sir. Please continue.
Actually, somebody or the other is continuously speaking.
Sir, let me. I will turn the microphones off.
So I'm जब आप बंद कर लो ना तब मेरे से बोल देना तो
Okay, so sir, just give me a second.
the presentation. अभी भी नॉइज आ रहा है पीछे से. Just ring me up when you stop.
Sir, can you please continue now? Hello? Hello?
Is it okay? Now can you hear? I mean, see? Now you got it? Okay. Okay. So actually, IPM is a systems approach. When we use IPM, we use systems approach. In a way, actually, when it is open field cultivation, we use wide area approach. The entire village data for the pests and the crops and the weeds is taken as a baseline, and then IPM module is synthesized. But in the protected cultivation, you mainly focus on the pests which are occurring time and again, and you keep a module ready. It is not that only those pests will come which are scheduled or which are expected. Some other pests will also come, and that can be handled then and there. So there are some solutions which you design in anticipation and some that you decide at the time. But integrated pest management actually is the integration of different components in such a way that you keep the pest population, you minimize the pest population below economic injury level. You do not eliminate fully and control fully. And in such a manner that you have to keep the environment sustainable, the farmer profitable, and the health of the health and the safety of the consumers using that product. So that is how our National Agriculture Policy in 2001 gave a special emphasis on IPM, because lot of intensive cultivation had caused damage So due to intensive cultivation during the Green Revolution, a lot of chemicalization of the agriculture had happened. That is why the nation adopted to the IPM policy. The main components of integrated pest management included the host plant resistance, regulatory measures, cultural practices, biological control, botanical pesticides, and chemical control. So you develop an IPM module which encompasses everything from environment to the system to the component to the inputs, which will be expected to control the pests that you do. For example, I'll give you an example. For example, if you are facing the nematode problem, then it is not that when the nematode will come and you will apply a chemical and it will be controlled. No, you have to apply IPM at all three main stages. Number one is pre-planting stage, number two is the monitoring stage, and number three is the implementation stage. The planning stage could be like feed preparation, for the selection of the variety, for the arranging of the inputs, everything. And then during the monitoring stage, the monitoring could be even pre-crop monitoring. So for example, if you are taking the soil sample before the crop, so you are determining the population of the nematode which is likely to occur, and during the crop, then you will monitor the root of the plant, the population of the plant, the observations you will take, and then during interventions, some interventions will be before the crop and some interventions will be during the crop. So IPM is a systems approach in terms of space and time, in terms of planning and in terms of application, and you do a holistic approach. So this happens not only with the nematode. If you are controlling an insect, for example, in the greenhouse, it is covered from all the sides. So big pests should not enter. For example, borers, they have the the moths. So male and female of the borers, if they are noticed or the caterpillar is noticed, then you have to apply the holistic approach. Number one, first you should see that how this borer entered the greenhouse. It should not have entered. But now that if it has entered, then you have to see that if one or two caterpillars are seen, you immediately remove them physically. At the same time, you use the light traps so that any moths that have entered are trapped and controlled. And then only you think of applying some safe or green molecules like neem or maybe spinosad, so that they are not harmful to the system. But if everything fails, then only you use hard chemicals. Similarly, you use biological control agents as far as possible. So you use botanicals and biologicals for managing the pests as far as possible. So cultural practices are mainly during the preparatory stage or during the sanitary phytosanitary measures. Cultural control, for example, if it is a soil-based greenhouse, then you have to manage the soil before the crop. But during the production, you have to maintain the hygiene and the maintenance, and the structure has to be such that there have to be two doors, and you don't enter the greenhouse without those precautions. So integrated pest management is not just one method. It is a philosophy. It is an approach which is taking control of everything. So IPM research uh, extends from total holistic system at the national level, at the farmer level, at the village level, and at the academic level for the synthesis of the modules, at the farm level for the validation of the module, at the university level, it is creation of the databases or things like that and basic methodologies, and in places like NCIPM, which is now NRI IPM, for leading the cooperating centers and developing the multi-state partnership with the state government, so that the entire nation is handling the pest at one level, and then it is at the field level. So IPM approach is actually a very holistic approach at the whole national level. It is not that every farmer has to do everything. Farmer can do only for his field. The only thing is that he has to take care of the surroundings. He has to be conscious enough, and he has to be recording the different pests and this thing. So major considerations for IPM validation is that the area has to be large as possible. In terms of open field cultivation, it has to be extensive baseline approach. In terms of greenhouse agriculture, you have to have your system-wide approach to the extent that how many greenhouses are in your area, what kind of pests they are facing, what kind of the pests you had last year, what kind of the problem could come. So these, you create a database and you create a module, and then you implement from pre-plant stage to monitoring stage to implement stage, and the support systems of the technical know-how, the inputs, the trained personnel, the scientific institution, the Krishi Vigyan Kendra. It is not that the entire knowledge is with you. So you have to take support systems for technicalities, for inputs, and for human resources. And then only the program sustainability can be achieved, and wherein you can create even an IPM group. If there are several greenhouse growers, you can create an IPM group of greenhouse growers to record the pests, to know the pests, to develop the program, to know about the chemical, and that is how the entire knowledge system of IPM will work. So you have to mend the structure, the compliance of the structure, the openness of the structure, the cleanliness of the structure, the specifications of the structure. For example, if it is an insect-proof net, then insect-proof net has to be of the right mesh size. It's not that you create an insect-proof net with 30 mesh size. So it has to be 40 to 50 mesh size only. So 50 mesh size is better, but aeration problem is there because the whole of the net is small, but it improves the avoidance of the pests, but at the cost of the circulation of the air. So you have to create some air circulation facilities. Similarly, selection of pest-resistant varieties or right kind of seedlings and transplants so that your crop is as pest-free as possible. If you're using disease seedlings, then nobody can help you. So it means if you are going to transplant a vegetable, or for example, tomato, you want to transplant, or cucumber you want to transplant, or capsicum you want to transplant, then you have to grow it in a safe insect-proof nursery, soil-less cultivation of the nursery, so that any pests and diseases do not enter the greenhouse in the first place. Similarly, integrated pest management also requires to use integrated nutrient management. The fertilizer dosages should be such that they are not giving advantage to the sucking pest, because if you use overuse of nitrogen will lead to the lot of vegetative growth. The plant growth will be green and juicy, and the crop canopy will be favorable. Crop microclimate will be स्वामी सर लेक्चर चल रहा है, मैं अभी कल करता हूँ. So fertilizer dosages should be such that they should not promote any sucking pest, for example. So if you are managing sucking pests in the greenhouses, you have to manage the fertilizer dosages also. So what they do is that if there are a lot of sucking pests, then you reduce the nitrogen dosages. You increase the potash dosages slightly, and then use whatever chemical that you are using, or biological control that you are using, or the botanicals that you are using, which will help you control the pests. It is not the chemical alone that will help. So you have to manage the system in a holistic manner, and you have to keep monitoring all the time, from before crop to during the crop and until the harvesting is done. So complete mapping, detection, identification, and population monitoring of the pests has to be done. If the greenhouse operation and maintenance is done that way, then only you will be able to manage a healthy production system, a clean production system. So hygiene of the greenhouse system is the first and foremost priority for the production system. The time is less, so I'm actually reducing the presentation. For example, these are pheromone traps they use in the use of plant extracts like rotenone, neem, pyrethrum, grunge, etc. Use of copper products and sulfur products, because the copper is antifungal by and large. It kills bacterial and fungal diseases, mainly fungal diseases. Similarly, sulfur. Sulfur is also antifungal. So copper and sulfur products, they are actually allowed in the organic production systems to certain level, and that is how you can manage either organic or safe production systems of greenhouse, the protected cultivation. Similarly, the biopesticides like spodicide, Bacillus thuringiensis, Bacillus subtilis, Vivera bassiana, Coriothyrum miniata, abamectin, spinosad, these are like green, are the beneficial biopesticide, or they are the green molecules which are good for such production systems. Similarly, the healthy crop production should be maintained through use of commercial pollinators, parasites, and predators. Now, this is one thing which is lacking in our country. The world leaders of the biologicals, for example, BioBee, BioBest, Coppert are some of the companies which are using biologically produced parasites and predators, which can control the pests without the chemicals. So biorational pesticides and biological origin products should be encouraged in the greenhouse production systems. Things like azadirachtin, pyrethrin, nucleopolyhedral viruses, granular viruses, horticultural oil and agro sprays and insecticidal soaps, or fish oil. These are the things which can be used safely against these things. So major biological control agents you can use against spider mites is the predatory mites, and for the white flies you can use predatory mites like Amblysys swirsky. For leaf miners you can use parasitic wasps. For aphids you can use parasitic wasps for like Aphidius columani. For thrips you can use predatory bugs like Aureus And for mealybugs, you can use predatory beetles like Cryptolemus monthrosarii. But the problem is that these are commercially not available in the country, and still they need to be imported. And the import protocols are very, very stringent. You have to plan several months in advance. The thing is that if you are doing integrated pest management, you have to maintain the sanitary and phytosanitary measures and the good agriculture practices. So integrated pest management, whereas it integrates all the pest management technologies, but it is a overall part of good agriculture practices. So if you are maintaining sanitary phytosanitary measures, hygiene, cultural practices, biological control, then you can avoid the chemical use of the fertilizers or pesticides to quite an extent. That is why they are part of the good agriculture practices. I'll tell you a little about good agriculture practices also. Good agriculture practices are nothing but, in my, if I were to speak, it's a comprising of responsible and responsive production systems in terms of profitability of the producers, health and biosafety of the consumers, and non-target organisms. For example, if you are controlling a pest, but you cannot kill the pollinator because that is not the target. If you are doing the agriculture in a very healthy manner, but the pesticides or the chemicals which are run off from your field and going to the lake in your area, and the fish is getting killed, then you are not sustaining the environment. So the production system has to be healthy and safe, not only for the consumers, but the non-target life. So good agriculture practices are basically dependent on four pillars. That is the economic viability for the producer, environmental sustainability for the planet, and social acceptability for the people at large, and the food quality and biosafety for the production system. So this is how this is a responsible and responsive production system, responsible for the economic viability and profitability of the farmer, responsibility towards the environment, responsibility towards the health and safety of the people and the non-target organism. At the same time, it is responsive. Responsive because it responds to the society, to the legal system, to the people at large, to the complaints, and to the redressal of the complaints for the workers, the health and safety of the workers, and the family at large. So that is why the healthy and good agriculture practices comprise, and that is why they are in line with the Sustainable Development Goals of the United Nations. You all know there are 17 Sustainable Development Goals of the United Nations. So good agriculture practices are just one of the measures to achieve the sustainable developmental goals in life for the planet, for the purpose and the health of the planet, of the soil, of the air, of the earth, of the water system, of the living beings, and for the new generations to come. So that is why good agriculture practices are in complete sync with the sustainable development goals of the world, and as envisaged by the United Nations. Now, how these good agriculture practices are achieved? So we say that it has to be economically viable, environmentally sustainable, socially acceptable, and ensuring food quality and safety. So we see that there are 14 major principles of good agriculture practices. First and foremost is the traceability. Suppose if you buy a vegetable from the market and it is a packed vegetable, for instance, there is a barcode on it. Then you have a scanner of the barcode, you are a member of that system. Then you can just hold on a minute, please. on-target salary. So, so it means in any good production system or in any system, if a system is transparent, then the system is good. If there is anything hidden, secretive, then there has to be something bad about it, most likely, until unless it is a national secret. So if a system is traceable and transparent and responsible, then the system is good. So major principles of GAP, the 14, the first and foremost is traceability, that if you pick up a vegetable from the market, it is, for example, packed vegetable and there is a barcode on it and you can read the barcode, and it is so traceable that you can trace where it was produced, how it was produced, when it was sown, what was the chemical used, and who produced it, who sprayed it, how many times it is sprayed it, what was the dose of the spray. You can trace out everything. But remember, this traceability is for a relationship between the producer and the retailer. So there is actually an agreement between the producer and the retailer. Good agriculture practices are not that everybody follows it. Good agriculture practice, you follow the good practices. But when you do a legally bound system with the good agriculture practices, then there is an agreement between the producer and the retailer. So the retailer will give the farmer the conditions that you produce such and such way, then only I will buy from it. Otherwise, if a farmer is producing, how he is producing, what he is spraying, nobody is bothered. People are bothered, but they cannot do anything about it. But if there is an agreed system between the buyer and the retailer, which is the global GAP system or India GAP system. Global GAP is the world authority in Germany, and every country has its own standards in the sense that the social acceptability issues vary from nation to nation. So the global GAP gives this leverage and gives this liberty to the nations to develop their own gaps. So, for example, there is a farmer in India and there is a buyer in the mandi. He says that you produce such and such vegetable with such and such a standard. And you will use this chemical and you will not use this chemical. You will use this variety, you will not use this variety. So there has to be an agreement. Once an agreement has been done, then the farmer has to keep record of everything. When was it sown? What was the variety? When it was transplanted? And how much spray was done? What chemical was done, used? And what fertilizer and how much fertilizer was used? Everything. And what was the health of the workers? Whether the hygiene system was there, the public toilets were there or not, or the insect or disease or pest, whatever, was monitored or not. And there was no entry of hidden animal or anything which is banned. So that is why the traceability is the most important principle. To maintain the traceability, you have to keep the record. You have to keep self-inspection. You have to keep self-audit. And you have to declare the varieties and root stock as per the agreement. You have to keep the site history and the site management of the entire production system, soil and substrate management system, the fertilizer use, irrigation, fertigation, frequency and the dosages, the crop protection measures, whatever you took, whatever was the dose, whatever was the chemical, whether it is allowed or not allowed, and the harvesting, whether it was done properly, the produce handling was safe, produce handling was neat and clean and hygienic and standard and as per demand. And the waste and pollution management in the area was followed or not. If the water was used, whether it was filtered or not, there were no heavy chemicals, heavy metals, stains, pesticides in the water that you're using. You have to ensure the quality of the water as per the agreed system. It may or may not be there. If the buyer is ready to accept to a certain level, he can allow, but then he cannot declare. He will have to declare that up to what level he has gone into an agreement with the farmer. So similarly, the worker health, safety, and welfare of the worker. It's not that the workers are hungry, workers are ill, workers are infective, uh, workers are tired, workers are worried, workers are tortured, and workers are child, or workers are unsafe women. Then the welfare of the society at a whole in the production system is not good, considered not good, and cannot be certified by the audit. That is why you have to have internal audit as well as external audit. Similarly, you have to address the environmental issues. For example, if there was hazard, for example, if there was a drum of chemical pesticide which was allowed in the agreement, but there was a spill of the pesticide, whether it was addressed or not. If there were polythene use, whether the polythene disposal was right or not, whether the polythene was burnt or disposed in the right manner. So all said and done, the 14th principle will be the complaint form, so that if there is a complaint from the retailer or from the market or from the agreed party, then whether the complaint form was given, whether the complaint form was admitted, whether the complaint form was recorded, and whether the complaints included in the complaint were addressed. If the complaints are not addressed by any system, then the system is not right. It cannot be certified as a system. That is why the complaint redressal form is the part of good agriculture practices also, and the good management practices also. Just like in the agriculture systems, in the industry, in the offices, there is a complaint redressal form. If any system is not addressing the complaints, then the system is not healthy. So it has to come on the front that what complaint was there, whether it was addressed and disposed in the right manner or not. The climate smart agriculture is these days the protected cultivation, and vertical farming and hydroponics. They are using a lot of sensor-based data, and the sensor for the use of the for the control of the moisture, for the control of the temperature, for the control of the uh, oxygen demand, bio-oxygen demand. These 6-7 kinds of sensors are used for the management of the light, for the management of the UV, for the management of the water quality, for the management of the temperature, management of the moisture. All these sensors data will be used for example, if you are going for the water quality, then what is the electrical conductivity of the water? What is the pH of the water? What is the TDS of the water? What is the ammonia concentration of the water? And what are the temperature or maybe even pesticide residue level? But that is higher level, not sensor based. So there are two things. Number one is sensor based and number two is analysis based. So sensors are nothing, but they are extension of the human body, so that the personal observation is avoided. If the personal attention is avoided, your efficiency increases. Otherwise, you will have to personally go and monitor everything. Every day you have to monitor EC several times, temperature several times, pH several times, which is humanly not possible for the entire system. Whereas in the sensor-based system, you can monitor the entire thing sitting at one place, and you address only the problem where it is occurring, and where whatever is the level of the attendant, it needs to be attended immediately, or so you can prioritize the addressal. So sensor gives you an opportunity to be there without being there. So you are monitoring the entire system with the health of, and that is how you can cover more area more precisely. So it is giving you the control over the system, and precise, unbiased control. Observations could be could be faulty, but sensors are, as long as they are working, they will never give the wrong information. So they're giving you the pH. So in the system, for example, the plants where a lot of high temperature is there, then for example, the pH will increase due to high evaporation and high metabolism. The pH will increase. There will be a lot of leaching of the salts, and there will be lack of absorption. So this high pH will lead to less absorption of the available nutrients. So that is why the climate smart agriculture these days, the climate related exigencies, emergencies, and extremities can be controlled by smart agriculture. Like geoponics, you are seeing pots with the clay balls, or the vertical systems, or the aeroponic systems, or hydroponic systems, depending upon the media that you are using. If you are using liquid medium, then it is hydroponic. If you are using air sprays for the hanging roots, that's so where your root is, the nomenclature is. So if your root is in the solid system, that is the geoponic. If your root is hanging freely in the air and you are giving a spray of the nutrients, then it is aeroponic. And if your root is hanging in the water, so that is either deep water or hydroponic technique. So basically they are all soil-less cultivation systems. Hydroponic is a general term which is used, but it is actually, specifically speaking, it is soil-less cultivation. So climate smart agriculture does this, the control of the environment with as much precision as possible. The thing is that it is digitally driven, and it is generating the precise data and big data for the automatic analysis and automation of the machinery like robots, drones, micro drones, fertigation machines. They are all actually using the sensor technologies and Internet of the Things, so that the entire system is connected to each other. And now that all can be integrated with artificial intelligence also, so that you can virtually be free of, and you can achieve in a way, in fact, without even human touch, you can control the entire system. So sustainable agriculture practices will use good agriculture practices, integrated pest management, safe and organic methodologies with the help of the sensors and automation machinery for ultimate automatic data-driven data collection, and lacing with the machinery and the robots and the computers and the IoTs and the mobiles and the laptops and tabs, whatever. Ultimately, you integrate everything and come out with a system which is virtually running all by himself, to the extent that you can achieve a touchless greenhouse where a human being will not even enter. And correlating with this are the marketing opportunities. For example, you see in the households, in the advanced household these days, there are refrigerators which are connected with your mobile. And if, for example, the juice is finished in the refrigerator, it will send a message to the local departmental store that please send the juice, it is finished, or please send the curd, it is finished, or please send the milk, it is finished. So even your machine is talking to the market. So similarly, the data, the production, the system, the plant, the machine, the human, the supply chain, the vehicles, the deliveries, they are all getting collated and concentrated, and they are all converging to achieve that level of automation. So this is how the sustainable production systems, there are a lot of things which can be talked about, but since my time was up to 12:15, it's already 12:23, barring 7-8 minutes of wastage at the time. And these days, you see it's world of blockchain system. wherein every activity, one activity is correlated with the other module of this chain of activities or chain of actions, which that is how they maintain the blockchains of automation. So everything can be blockchained, wherein every event and every action is digitally or manually changed into action and reporting. So everything is action, chain, reporting, and documentation. That is how the blockchains work. So that is completely opposite the traditional farming system where the monitoring will individual monitoring and trust will be required. But here, the entire thing can be done through machines. But of course, the basic knowledge has to be there, which has to be incorporated into the system. Then every system, every crop, these things will vary. Depending upon, for example, you may require raw fruits or the mature fruits. You will have to feed this to the system. These days, even the harvesting system has been automated, wherein the robots are fully equipped to understand whichever is the mature fruit and which is not, depending upon the size, depending upon the color, even depending upon in future maybe possible through aroma and through gaseous exchange. So ultimately, the automation and the good agriculture practices, they will, and the data management through data management and automation ultimately will achieve the best possible and precisely maintained agriculture. This is one of the bulletins that I published long back. You can download from the internet. It's free of cost. Similarly, Dr. Hassan has published one bulletin on hydroponics. You can download. I'll not go into policy and those things. Discussed in brief about the production systems. So for good agriculture practices, you can see EPIDA website. For bananas, mangoes, or pomegranate and grapes, you can see EPIDA supports GAP for pest management and exporting to Australia, Russia, and Singapore. So similarly for food safety also, you can see some websites where you get good idea on these systems. So with this, I'll like to open the system for. These are some books we have published. These are the success stories of some farmers that we are dealing with. Thanks a lot, and I'll welcome any questions if there are.
Thank you, sir. Participants, if you have any questions, please ask. We have turned your microphones on one by one.